Hello and welcome to Layer Zero, where we create videos that break down complex topics into mathematical foundation and intuitive understanding. And welcome to our series Demystifying AI from the Basics, where we talk about what AI is all about and how they apply to us, whether we use them to excel at work, keep up with school, or for any other reason. I will demystify and break down AI concepts so that you too are knowledgeable to understand the transformation that is happening now. So, what's going to be in this video? We're going to see the history of how AI came to be, what is AI, and the glimpse under the AI umbrella. So, let's start with history. AI started all the way from 1950 when Alan Turing publishes Computing Machinery and Intelligence. In this paper, he asks, can machines think? It is from here that he offers a test that is now famously known as the Turing test, where a human interrogator would have to identify if the subject is a computer or a human based on their replies to various questions asked. This test determines if a computer is able to communicate convincingly just like us. 1956, John McCarthy coins the term artificial intelligence at the Dartmouth College workshop. And this was the first AI held conference. And then in 1958, he went out to invent Lisp for AI research, and then it got pioneered into many core computer science concepts that are still standard today. From 1964 to 1966, we see Joseph Weissenbaum creating Eliza, the world's first AI chatbot, which laid the groundwork for modern conversational AI. Now we come to the first AI winter that occurred between 1970s to 1990s. And this was due to the massive drop in funding and interest in AI. This was occurring due to two major critics. The first one, the ALPAC report commissioned by the US government. It concluded that machine translation was vastly expensive and had low accuracy compared to a human. Next, the Lighthill Report review of the British AI research by mathematician Sir James Lighthill, which concluded that the field's core assumptions were fundamentally flawed. One such assumption is if AI could solve problems in the toy domains, that are environments made only with color blocks, it would be easy to generalize the messy and unpredictable real world. Then, after this long winter, came a spark at 1997, where IBM's Deep Blue beats the world chess champion Garry Kasparov in a chess match. In 2011, IBM Watson beats champions Ken Jennings and Brad Rutter at Jeopardy! In 2012, AlexNet, submitted by Alex Krzyzewski, alias Sutsker, and Jeffrey Hinton in 2012, a deep conversational neural network that revolutionized AI. The success of AlexNet is widely considered the catalyst for modern deep learning boom. It demonstrated that neural networks could scale successfully if more data and computing power is given. And this paved way for advancements in speech recognition, natural language processing, and generative AI. In 2016, DeepMind's AlphaGo program beats Lee Sedol, the world champion Go player. Later, Google purchased DeepMind for a reported $400 million. In 2017, Google published a paper called Attention is All You Need, providing the blueprint called the transformers for the first true LLMs. In 2020s, generative AI transitioned from experimental research to early stage integration in content production. The industry has largely shifted from basic AI assistants to human in the lead production workflows, where content creators use AI to speed up the early stages of production while focusing on their human expertise on curation, editing, and strategy. OpenAI released ChatGPT as a free research preview on November 30th, 2022, marking a huge shift in public access to generative AI. Built on the GPT 3.5 large language model, it became the fastest growing consumer application in history by surpassing 100 million users in just 2 months. From 2023 to 2024, it marked the breakout era for large multimodal models. The industry shifted from isolated unimodal systems that are text-based only or image only to integrated frameworks capable of natively processing and generating combinations of text, audio, images, and video. Now we are coming closer to today, and in 2025, generative AI achieved a 53% global adoption rate within just 3 years of public availability. And this far outstripped the historical rollout speeds of both the personal computer and the internet. Simultaneously, the proliferation of workspace software integrations drove a 50% increase in employee access to AI productivity tools. This year, in 2026, AI is evolving from passive prompt and response chat interfaces into agentic AI. These autonomous agents can execute complex multi-hour workflows across various different software platforms and leveraging internal tools to reason, plan, self-correct, and complete multi-step business operations without human intervention. The technology gap between the top-tier US frontier models and their Chinese leading counterparts has drastically narrowed to mere 2.7 capability gap. This margin is effectively considered closed, down from a 17% to 31% performance gap tracked back in 2023, turning the AI landscape into a tightly clustered global race. Enterprises have moved aggressively past the proof of concept phase. Roughly 54% of all corporate AI experiments are successfully transitioning into full-scale production environments within 6 months of deployment, marking a massive stabilization in enterprise infrastructure. Now that we have seen the history from all the way from 1950 to this year 2026, let us look into what is AI. AI is nothing but a huge broadest concept encapsulating machine learning, deep learning, and generative AI, and it refers to any technique or system that mimics human intelligence so that it can solve problems, perform tasks, or even make decisions. But how does this work? It works as AI learns from examples. You feed it millions of pieces of data and it starts spotting patterns all on its own, and then uses those patterns to make predictions or decisions. It's less like programming where a computer has strict rules and more like learning by example. The same way you would recognize a dog by seeing thousands of pictures of it, but not memorizing a definition. And we have seen this everywhere. You've probably used AI multiple times today without even noticing it. It's the reason Google Map knows the fastest route home, why a shopping app seems to get your taste, and why the spam never hits your inbox. So why does this matter? It actually matters because AI is helping researchers speed up medical breakouts, helping companies build smarter and more efficient supply chains, and giving us new tools to tackle huge problems like climate change. The same technology that suggests the fastest route home is also pointed at some of the world's hardest problems. Now that you've been introduced to AI, let us see what is under this AI umbrella. So we can see there are a lot of components in this bubble. And let me explain them. Machine learning. These are systems that are learning patterns from the data without explicit programming. Deep learning. It is a specialized subset of machine learning that uses deep neural networks. Computer vision. It enables computers to see and interpret visual information. Natural language processing, or in short NLP, allows the machines to understand and generate human language. Robotics. By combining hardware and AI, we can perform physical tasks autonomously. Knowledge representation and reasoning. The information is structured so machines can solve complex problems logically. Now, in advanced AI systems, these fields do not operate in isolation. They actively feed the data and the capabilities into one another. For instance, deep learning powers computer vision and NLP. Deep learning algorithms acts as an engine behind modern speech recognition and image detection. Computer vision and NLP guide robotics. A physical robot sees or uses vision to see its environment and NLP to understand user commands. Machine learning also organizes knowledge. Machine learning models extract facts from raw data to build structured knowledge bases. Now that we have seen how these different fields are not operating in isolation but rather together, let us look at a real world example. In Amazon's advanced robotic warehouses, in these massive facilities, there are thousands of autonomous drive units and robotic arms that work alongside human workers to process millions of packages every day. Amazon has deployed more than 1 million of these robots across its operations network since the first acquiring of the robotics company behind them in 2012. The entire operation pipeline serves as a living laboratory where every major discipline under the AI umbrella interacts simultaneously to solve a complex and a high-throughput logistic challenge. The process starts with computer vision, the physical eyes of the warehouse. You can see this in Vulcan, Amazon's first robot built with a sense of touch. It uses a camera mounted on its arm to scan the storage bin, pick out the right item, and confirm visually that it grabbed the correct one before letting go. Another robotic arm, Sparrow, does something similar. It uses computer vision and AI to identify individual items and sort them into the right tote. Spotting the package is only half the job. The system also needs to know where the package goes. And that's the role of Sequoia, Amazon's inventory system. It uses AI and computer vision together to figure out the fastest, most space-efficient way to store and retrieve inventory. This speeds up how quickly items get identified and shelved at a fulfillment center. Once the destination is known, machine learning takes over the planning. This is where drive units like Hercules and Titan come in. They physically fetch shelves or pods of inventory and bring them to human workers. But the route they take isn't hard-coded. Hercules uses a forward-facing 3D camera to tell people, pods, and other robots apart. And then it adjusts the part in real time to stay safe and efficient. Titan does the same job but can carry roughly twice the weight, so it's reserved for bulkier items. Then for physical movement like lifting, gripping, and carrying. Robin and Cardinal are the arms responsible for this at the outbound stage. Robin lifts package off the conveyor belt and loads them into the drive units, while Cardinal uses air suction to pick up a single package out of that pile, reads its label, and place it in the right cart. And Proteus, Amazon's first fully autonomous mobile robot, then carries those loaded carts across the warehouse to the loading dock, navigating around people and objects all on its own rather than following a fixed track. This is actually where robots are next headed. NLP. The newest version of Proteus is being built so employees can direct it using plain and conversational prompts instead of using technical commands. If you tell it what needs to be done, it works out the priority, route, and the timing all by itself. So let's recap. We saw the history of how AI from 1950s to today has evolved. We also looked into what AI is all about and also what is under it, under this AI umbrella, and also a real life example of how different disciplines of AI interact with each other with an example. Now that we have been well introduced to AI and we have learned how they interact and apply in the real world, in the next video we will deep dive and demystify into the different layers of AI and its applications. So see you all in the next video.